lecture for our example number 1, which is the design of N type of foot overbridge. So students, first of all, in the last lecture, we will discuss up to our step number 7, which is the forces on top board. Okay, but in the last lecture, there will be some doubts. Okay, so first of all we will solve your doubts because some students ask me the doubts of the step number 7. Okay, so students, in the last lecture we will discuss up to our step number 7. So first of all, whenever you are arise any doubts, so we are discussing from step number 5, which is the load on main members. So you can consider that this is your width of walkway, and the width of walkway is up to 4 meter because in the question it is clearly mentioned that your width of walkway is 4 meter. Now your one main truss arrangement is over this side and another main truss arrangement over this side, and the distance between these two main trusses arrangement is 4 meter, which is the width of walkway. Now whenever you have to design any structure, then you have to design that structure like your structure is safe as well as your structure is economical. Okay, now at that point of view you have to design your any component for economical point of view, so you have to design it for minimum weight. Okay, because you have to design it for economical. Now this is your through type of foot over bridge, and you all know that in through type of foot over bridge your supporting system is on the bottom chord. Okay, so first of all we have to find out the forces on main members or the load on main members. So at that time there are main three loads are considered. So first load is dead load of slab. Now what is the value of dead load of slab? So you all know that in the slab it is clearly mentioned that you have to use RCC slab. Okay, now the density of RCC is 25 and the thickness of RCC is 110 mm. So it is 25 into 0.11 because 110 is in the unit of mm. So we have to convert mm to meter. So it is 25 into 0.11, and the answer of 25 into 0.11 is 2.75. Now the distance between these two main arrangement is 4 meters. So half of the load is transferred to this truss system and half of the load is transferred to this truss system. Okay. So it is 5.5 kilonewton per meter. At the same time, your floor finish is also like this. So it is 0.75 into 4 by 2, which is equal to 1.5. Your third main load is live load, or live load is considered as your moving load. So the value of moving load is given as 5 kilonewton per meter square. So your 5 kilonewton per meter square's half load is transferred to the left side and half of the load is transferred to the right side. So it is 5 into 4 by 2, which is equal to 10. Now after calculating these three main loads, now we are assuming that the self-weight of all the components. Okay, so in the your book the self-weight of main member is considered as 0.7 kilonewton per meter. So for exam point of view, you have to consider the self-weight of main member is in the range of 0.4 to 1 kilonewton per meter. Okay, so students, in this example you can see that we have to calculate the dead load and live load calculations separately. Why? So the reason behind the calculation of dead load and live load separately is just we can design for vertical member and diagonal member. At that time some of the member is designed for compression and some of the portion is designed for tension. At that time we have to separate calculation of loads like dead load and live load separately. Okay, so for that point of view, we have to find out your dead load and live load separately over here. Okay. Now your total dead load is 7.7 kilonewton per meter, but this dead load is your working dead load. So we have to find out factor dead load. So it is 11.6 kilonewton per meter. Now just like your dead load, your live load which is equal to 10, so this 10 is also a working load. So your factor live load is 15 kilonewton per meter. Okay. Now after calculating factor dead load and factor live load, you have to summation of both the values. So your factor total load, which is the summation of factor dead load plus factor live load, which is equal to 26.6. Okay. So why you have to summation of these two values? So your top code member and your bottom code member is always in two type of truss. Your top code member is in compression and your bottom code member is in tension always. Okay. So at that time, whenever your all the components like all the members of top code is in compression and all the members of bottom code is in the tension. So at that time you have to calculate total force. But for vertical member and for diagonal member, whenever some of the portion is in tension and some of the portion is in compression, so at that time you have to consider separate dead load and separate live load. Okay. Now your next step is analyze of lattice girder. So in this step, we have to just given the name of all the junctions. Okay. So you can see that this is your first junction and this is your top code. So the name of this top code is considered as your upper code. So it is U0, U1, U2, U3 up to U8. And at the same time, this is your bottom code and bottom considered as lower. This is upper and this is lower. So it is L0, L1, L2, L3 up to L8. Okay. Now we are moving further to our step number 7, which is the forces on top code. Now your first member is U0, U1. So from U0, U1, at which point your forces is maximum? So you have to consider that U1, U1, sorry, U0, U1's opposite end. So U0, U1's opposite end is L0, L1. Now you can see that from from U0, U1, one diagonal member which is U0, L1 is connected at L1 point. Okay, so whenever you have to design for top code, for you have to consider opposite end and at which point your diagonal member is acting, at that point your force is maximum. Okay, in some reference book and in some other books this type of funda is given. Okay, you have to consider just opposite end and the diagonal member is acting at which point, at that point your force is maximum. Okay, now you can see that this is L1. So at this point for first member your force is maximum. Now the left distance is considered as a distance. So over here your value of small a is 3 meter and your right portion, so the distance of right portion is 21 meter. Okay, because total length is 24 meter in which your left portion is 3 meters, so your right portion is 21 meter. Now what is the value of this point? So the value of this point is find out from the equation a into L minus A divided by L into H. Okay, now you all know that your value of small a is 3 meter, your L which is the span of bridge which is equal to 24 meter, Your small a is 3 meter, your small l which is equal to 24 meter, and your h is equal to 3 meter. So students, after putting all this value, we will get our answer 0.875. Similar calculation for our second span which is equal to u1 u2. Now same funda. What is the opposite end of u1 u2? It is l1 l2. Now from u1 u2, your one diagonal member is acting at l2 point. Okay. So at this point your force is maximum. Okay. Now what is the value of small a? So your value of small a is 6 now, and your value of right hand side which is equal to 18. Okay, so students, after putting this equation and all the values, we will get our answer 1.5. For third member which is equal to u2 u3, your maximum force on topcoat member is at the point of L3, and for fourth member it is for L4. Okay, so students, after putting all this value, you will get your answer is 0.875, 1.5, 1.875 and 2 respectively. Okay, now this is just your influence line diagram. Now we have to find out forces. Now what is the equation of force? So the equation of force is the area of influence line diagram into intensity of load. Okay, so the value of intensity of load is 26.6, which is already calculated. Okay, so your area of this influence line diagram into intensity of load, so you will get your answer of all the forces of all the members. So you can see that your first member is u0 u1, and the equation is area of ILD which is equal to triangle. So the area of triangle is 1/2 base altitude into total UDL which is equal to 26.6. So you will get your answer 279.3 kilonewton. For similar type of calculation, your second span is U1 U2. So the area of ILD is 1/2 base altitude into 26.6, and you will get your answer 478.8 kilonewton. For third member, it is U2 U3. So the equation is 1/2 base altitude into intensity of dead load which is equal to 598.5 kilonewton. And at last, your last member, 4 member, is U3 U4, and the equation is 1/2 base altitude into intensity of dead load. So you will get your answer 634 kilonewton. Okay. Now it is already discussed that in through type of foot over bridge, your top chord member is always in compression and your bottom chord member is always in tension. So we have to design for maximum force. Okay, if you are pass in your maximum force, then it is always you are pass in your smaller forces. Okay, so your maximum force is 638.4 kilonewton. Okay, now you all know that it is already discussed in your semester 6 subject elementary structural design, in which there is one chapter named as design of compression member. So whenever you have to design for compression member, you have to refer the page number 34. Okay, on page number 34, the equation is given as PD is equal to A into FCD. Now, what is PD? PD means design compression force, design compressive force. AE means effective area, and FCD means design stress. Okay, it is design compressive stress. Now you have to find out for maximum force, and whenever we have to design for compression member, we are using this tables which is given on page number 42. There are four buckling class A, B, C and D. But for angle ISA, Indian Standard Angle, we have to refer only buckling class C as per page number 44 close. Okay, you can see that on page number 44, it is clearly mentioned that for any type of angles, you have to refer buckling class C. Now, we are moving further to the design of top chord. So, our maximum force is 638.4 kilonewton. Now, you have two methods to design. Okay, so in first method, you have to assume that your slenderness ratio is 100. And in the second method, you have to directly assume the value of FCD is equal to 100. Now, we are referring our first method which is given in our book. So our value of slenderness ratio is 100. So whenever your slenderness ratio is 100, so you can see that for slenderness ratio which is equal to KL upon R and our value of Fy is 250. So for 250, the value of 100 which is equal to 107. So our value of FCD is 107 megapascal. Now we are putting our value of FCD in the equation of PD is equal to A into FCD and we will get our answer of AE, which is area required. So after putting all this value, we will get our answer 5966 mm square. Now this is too much area. So we are providing two ISA back to back Indian standard angle. Okay. You are also provided single IS angle, but for safer side we are providing two back-to-back Indian standard angles. So let us, you can see that, try. This is not our final answer, but let us try our two Indian standard angle. So you have to provided your Indian standard angle having the value of area 5966 mm square. So we have to try two Indian standard angle 150 cross 115 cross 12 on both the sides of gusset plate with longer legs horizontal. Okay, so this value is referred from steel table, and from steel table it is clearly mentioned that for 150 cross 115 cross 12 mm, your area provided is 6076 mm square. Okay, now after finding out A, our second value is radius of gyration. So the value of radius of gyration is 33.7 mm, which is RZZ, and RYY is the average value. So our average value is 70.55. Now we have to find out slenderness ratio. So the equation of slenderness ratio is KL upon R. From this step, we have to refer two methods. First method is from book, and second method you have to find out KL upon R minimum. So that's why you have to put this value because this is your R minimum. Okay. Now what is KL? KL means effective length. So you all know that if your both the ends are hinged or simple or pinned, then your value of KL is equal to L. It is already discussed in your past semester. Okay, but you are also referring your page number 48 in which clause number 7.5.2.1, it is clearly mentioned that your value of K is 0.85. Now what is L? L is equal to 3 meter because your main member having the length of 3 member and it is 2 ISA. So 3 into 2 which is equal to 6 mm, 6000 mm. So your KL upon R average which is equal to 72.30, and at the same time your second method is KL upon R minimum. Okay, from here you have refer your two answers. Okay. Now, for KL upon R minimum, you will get your answer of FCD from this table. Say, for example, your answer in this example is 72.80. So, you can see that the value of FCD for KL upon R is equal to 70, which is equal to 152, and for 80, it is 136. So you can see that with the increasing in the value of slenderness ratio, your value of FCD is decreased. Okay. Now you have to find out the value of FCD with the help of interpolation. Okay. So whenever we have to find out our value of FCD with the interpolation, it is 148.32 Newton per mm square. Now this is our FCD provided and this is our area provided. After putting these two values, let us check our selected section takes how much load. So our AE is 6076 and our FCD is 148.32. So you can see that it takes the maximum force of 901.19 kilonewton, which is far more than the required. Okay, so now our selected section is now our final section. Okay, students. So this is the method of how to design our compression member. Now in the next lecture, we will discuss about our next step, which is the forces of bottom chord. Okay. So thank you for today's session.